what does polygon stand for?
Five-sided shape.
All right, let me ask you this. What does the word poly mean, or what does the word poly mean in Greek?
More
What
than
is
one.
it? Many. It means many. What is gon then?
God.
Shape.
Sides. So this is the Greek word for many-sided figure. We talk about it in terms of what are called many-sided figures. And the way that we look at it as we go into these, it's more of, excuse me. I got some stashes over here. I'll get some wrap here.
Kevin, I would just bring my computers. I don't know, after.
Oh, I hated that.
Stop that. So, as we go through these, well, good morning. How are you? I'm fantastic. Thanks for asking. Thank you. Appreciate it. She's not here. What's that?
A triangle.
How many sides does it have?
Three.
Okay. So 3 sides. It's called a triangle.
Try.
What's a 4-sided figure called?
Square.
Nope.
Rectangle.
Nope. What is it? Quadrilateral.
Oh my gosh.
Okay. Let's see how badly I can draw this.
Pentagon.
Pentagon. 5-sided pentagon. Let me move this up a little bit here.
Mr. Murphy, could you scroll back up just a little bit? Tag. Thank you.
Uh-huh. We have a pentagon.
What is this?
6 is going to be the. Now, if you were in Schaumburg yesterday, you probably went to IKEA. And at IKEA, everything is made with.
How'd you know? IKEA. I always get lost.
It's great. I was just guessing.
Yeah, I saw all your Snapchats.
Yeah, you guys thought that you're funny. But
There's your
They are
hexagon.
funny. So many people
And I
say-
joke about that with the whole IKEA thing, is that everything is put together from IKEA with Allen wrenches. I hate that. It's so hard to put it, well, it's not like it's difficult to put together, but it's a pain in the butt. So, my top tip for you, if you learn anything about geometry, which you probably forget, you'll remember hopefully 3, 4, 5 triangles, that's how you measure everything. And if you go and you buy anything from IKEA, buy the drill bit driver for a cordless drill to use for hexagons. Or instead of using the little Allen wrench, you know what that is, the little L wrenches? Get one that's shaped like a screwdriver because you can actually use it. You're welcome.
Thank you.
7 sides.
Hepta.
There's 2 names for it. Hepta is one of them.
What?
7 gram. It's gone.
Oh wow, that's really good.
Yes. 7-sided figure, there's 2 names. There's one, it's called a heptagon or a septagon.
I've never heard septagon.
Which one?
Septagon.
So, the 7-sided figure is weird, and it's got 2 names to it. Sometimes they're referred to it as a heptagon, sometimes they're referred to as a septagon. The reason that I'm going through all of these names is that way, if I ever, on a quiz or something, say, hey, you have a hexagon, you have to know how many sides there are. Okay. What has 8 sides?
Octagon.
There's your octagon. I'm getting lazy with my drawing, I'm sorry.
Non-the-ground.
What's 9 called? It's nonagon.
Oh.
A 9-sided figure. Guys, a 9-sided figure is called a nonagon. If you can't draw that, just say 9 sides. Really. A 10-sided figure. Decagon. Very good.
Wait.
Can I slide up? We okay?
Yeah.
No.
Well, you gotta be past that. You gotta be an octagon by now.
I'm still trying to.
Don't worry about drawing it. Don't worry about drawing it.
Nonagon.
Right me. Oh, there's a dog next to it.
Yeah, there is a donut somewhere.
Usually, what I go up through is 12, and that's your dodecagon. Because after 12, everything's just called something gon. It's called an n-gon. Whatever number of sides there are, if there's 30 sides, it'd be a 30 gon. If it's 17 sides, it'd be 17 gon, and so on and so forth.
Why is it gone?
So yeah, they did get lazy. The 11 sided figure, excuse me, is called a, well, unfortunately, there is a word for it, but I don't use it. It's a unagon. I forgot what it was. So we just call it an 11 gon. 11 gon. We got a little lazy. There is a name for it. I forgot what. I think it was ungon. I don't know. And then the last one that I ever hold you guys accountable for knowing is 12, and that's the dodecagon.
That's just a circle.
No. Remember, a circle is defined completely differently than a polygon. Polygons have sides. Circles don't have sides. Circles are a set of points that are all equidistant to a center. Okay? That's why there's curvature. All right? That's why all radii inside of a circle are the same. If you have a decagon or anything else, if this is the center, the distance from here to the vertex is longer than it is from here to the side. Okay? Yes, sir?
11-sided polygons named pentagon.
What? Pentagon? Oh, that's a different word. We heard something else first hour. I think it was unagon.
Kevin.
How about 11
Oh yeah,
gon?
it is.
I need it.
Pentagon or pentagon.
You have never used
Actually, I.
How about 11 gon?
Yeah, you can use that.
I've never used
I was just telling you.
Thank you. I
They
appreciate it.
do. What?
So, like I said,
Open it.
guys, like I said,
Give me.
these are the ones I'm going to hold you guys accountable for knowing. So if you see, hey, there's a decagon, you have to know how many sides that is. Okay. Now, the other thing that comes in with this is when we're talking about what's called convex versus concave.
Oh. Wait, were you coming?
Okay. We have to think about the two different terms.
What she said.
So, I know you guys have all heard those two terms before. What I think the easier of the two to define is concave. Concave means it's pointing inward. It's moving inward. You know how people say, oh, he's got a concave chest because his rib cage is concaved inward here. Concave polygons move inward. Okay, concave, they move inward at somewhere. We normally don't worry about that. There will be times that you can, excuse me, there will be times that you will see them, but a lot of the stuff that we focus at all in regular old boring geometry is with what are called convex polygons. Convex polygons are the normal ones. That's what none of the sides are moving inward. All the sides are moving around the outside. Like I said, if you have a six-sided figure, it's still considered a hexagon. It's a non-regular hexagon, but it's still a hexagon. It still has six sides. Nothing is moving inward. So that's just a regular old boring polygon, or excuse me, a convex polygon. That's normally what we worry about. Okay. And then the last term that for right now is what we call a regular polygon. We actually looked at this before. What did you know about an equilateral triangle? Guess how many sides? That equilateral triangle has 4 sides? Wow, that's impressive. Anyway, what did we know about the equilateral triangle?
All sides.
All sides are equal, and what do we know about all angles then?
They're all the same.
They're all the same. So basically what happened was an equilateral triangle is a regular polygon. It's the specific, okay? A regular polygon has all same sides, all same angles. Yes, sir?
So what a special right triangle was 1 and 2?
No, the special right triangle, the 30, 60, 90, is built out of an equilateral triangle. Because a 30, 60, 90 would has all three different side lengths, but the equilateral triangle has all the same size, same angles. So regular polygons, there's all sides. All sides and angles are the same, okay? And we actually talk a lot about different things with regular polygons, and I'll start listing those out as we go along. Excuse me. All right. Well, let's talk about angles. Interior angles. Where do you think interior angles in a polygon are? You're wrong. They're on the inside of the polygon. It's pretty. And what we look at is we figure out the sum of the interior. And there's a way to do this really easily. No, don't draw these. I'm just going to put up a couple real quick. How many degrees are on the inside of a triangle?
Oh,
It's like
180.
the Mexican dude from Napoleon Dynamite.
There's 180 degrees in a triangle. Do you agree?
Yes.
Does that ever change?
No.
So if I go to the quadrilateral, how many triangles can I put in there that don't overlap? Two. So there's 180 here, 180 there. So how many would I be able to put in a pentagon?
5. No, 2.
3 angles, or 3 triangles, excuse me. How many do you think I can get into the hexagon?
As many as you want.
1, 2, 3, 4.
5.
But if you make them really small, you can probably show this.
Once again, let me explain this again. How many can I draw in there that don't overlap? The answer is 4. Now, 3 sides had how many triangles? 3 sides had how many triangles? 1. 4 sides had how many triangles? 5 sides had, 6 had, 4. How many will 7 have?
9. 11. 2, 3, 4, 5.
How many do you think 8 will?
6.
How many will 10 have?
7.
10.
Oh, 10, sorry. Wait, what?
So let's start over. I said, how many did 7 have?
7, 4,
What?
5.
8 had. 8 will have how many? 6. 10 will have how many?
Oh.
8. What are you doing to figure this out? Subtracting how much? 2.
I wasn't on
So
my life.
the sum of the interior angles equals
Psych.
number of sides minus 2 times 1/8. Sum of the interior. Number of sides minus 2 times 180. Okay. Well, if I go think about it the other way,
What is that in stand for?
number of sides. I'll write that on here. Then I want to think about exterior. Exterior angles are angles where? On the outside. Okay? So if I go back and look at my pictures here real quick, my exterior angles were those. They're going around the outside. Well, if I'm going around the outside of something, how long does it take me to get all the way around? If I'm going around an object, how many degrees are around an object? Does that ever change? Every single time, the sum of the exterior, no matter what, however many sides there are, is always going to equal 360. Always. So to get around the outside is always 360. And you're going to see a reason why I always like to work with the outside angles more often than the inside because the math is less complicated. Yes, sir? Yeah.
I noticed because you said, you know how you working with triangles, you said like the line.
Yeah.
When you said you did the sides that didn't touch.
Yeah.
It's equal to
What? These? For what?
Oh, no.
Oh, you mean, oh, yes, I'm sorry. Yes, you're right. 'Cause you're doing the exterior angle. You're right. That's exactly where this comes from. What he saw here, guys, we know that in a triangle that's equilateral, all three angles are the same. They're all 60. So if these are all 60 degrees, if that's 60, 60, remember the outside angle is equal to the two it doesn't touch? That means it's 120, which means that's 120, which means that's 120, which means all the way around is 60. That's how all this comes back to work. It's crazy how math has a way of showing how it works. Okay. Now, what's that?
Like repeating its past.
Yeah. Now with these things, the pictures that I drew up there, well, that I so perfectly drew, those were all regular polygons because all those sides and all those angles will always be the same. When I press the button, that's what it does. They don't necessarily have to look like that. You could have them look a little bit weird. For example, what's that? This is your one time for this week.
Okay, I didn't do it all last week.
It's only Tuesday. Just want to let you know.
Riley, no one asked.
Real quick, does this look like a regular polygon?
We have a 4-day week last week too.
Regular polygon is going to have all the same sides, all the same, it's just an accident. We'll have all the same sides, all the same angles. Okay? Do all of those angles, are all of them the same?
No.
So you know it's not regular. Shh. But how many angles are there? There's 5 of them. What we could do is then figure out what all the angles have to add up to equal by using that. So if there's 5 angles, it means how many sides does there have to be? 5. So what's 5 minus 2? What's 3 times 180? You guys have calculators?
Wait, no.
It's 540. So all of these angles have to add up to equal how much?
Be nice before.
What's happening here, guys, is that you're going to be creating your own equation. All right, you're going to create your own equation by figuring out how many degrees are inside the object, and then just listing them out. Okay. That's what a lot of this stuff comes down to be able to do, right? Yes, sir?
Should we have to write all that?
You're probably, at this point, once you know that these have to equal 540, you're basically throwing it in your calculator. You're done. Now, that doesn't mean that sometimes you might see something like, I'll go back to it, I'll go back. If I go back and look at this one, same idea, but I have an x and a 2x, which means I have 3x, and then I have to add up all the rest of the other chunk. That's all it is. All right. Now, did you guys, do I have to show you how to subtract in your calculator, or you'll be okay? Yeah, good.
Yep.
Now, the other thing I want to go back to is this idea of the regular polygon. When you have the regular polygons, you know that all the angles have to be the same, all the sides will have to be the same. Usually when we're dealing with the polygon stuff, we're probably more than likely working with just angles. We don't worry about our side lengths until later on. We'll worry about those when we get into, I think, 11, when we deal with surface areas and volumes and stuff. Okay. Now, what I want you to think of is if I'm working with, I don't know, an octagon, and I want to find the measure of each interior angle. Find the measure of each interior angle in a regular octagon. There's a couple of ways of going about solving this. There's a very formulaic way, and there's a more intuitive, kind of logical way, and I'll show you both. Some people like one way versus the other. If one thing that I can definitely do is that I can figure out how many degrees are in the octagon, okay? Because I know this formula, the sum of the interior. Ooh, sum of the exterior. How much did the exterior equal again? Did it ever change? So if I want to figure out the number of sides, or I'm sorry, the number of angle or degrees total, it would be n minus 2 times 180. But then I want you to think about what you would do to figure out each angle. If this gives you the total sum, how many angles would you have to divide it by? How many angles? Shut it off. 8. In this case, you'd have to divide it by 8. 8 represents what?
The number of sides.
Number of sides. So to find each individual angle, one way you can do this, find each interior angle in regular polygon. We do this. N minus 2 times 180 divided by the number of sides. You did that with triangles. If we knew that there's 180 degrees in a triangle and all 3 of them are the same, you took 180 divided by 3. Well, what's the number of sides in a triangle? It's not a trick question. How many sides are in a triangle? 3. What's 3 minus 2? What's 1 times 180?
180.
What's 180 divided by 3? How about just 60? You said 160. Yeah. Each one is 6. That's what you meant, right? You basically did that, but the math was so easy because you were multiplying by ones and stuff like that. It wasn't a big deal. So what you're doing here is you can put this in your calculator exactly like this, but instead of using n, what number are you going to replace that with? 8. You throw it in your calculator just like that, and that'll tell you the measure of each individual angle. Okay? Or there's another way of doing it. How many exterior angles are there in an octagon? 8. Because there's 8 interior, which means there has to be how many outside? 8. How many degrees are on the outside? Does that ever change? No. So the other way that you can do this,
Wait, how many degrees are on that side? Alright, thank you.
if you take 360, divide it by the number of sides, or angles if you will, it'll give you the measure of the outside angle. Don't these two form a linear pair? So to get the inside angle, wouldn't it just be its supplement? What's the supplement of 45?
135.
Isn't that what you got when you did that? A lot of times it's easier to work on the outside way. Or do it this way. Take 180, subtract 360 divided by n. Two ways to do it. Honestly, I think working with the exterior angles is easier. That's just me, okay? Because you're working on the outside, going inward. It's actually much easier to do that also. We use that method a lot more later on when we get back to polygons, when we're talking about what's called perimeter apophyll, about finding areas and stuff. It's so much easier to set up the outside angle and just work inward. So if you get accustomed to working outside in by taking 360 over n, subtract that from 180, that will always give you that each interior angle. Okay. Let me show you an example again. If I want to find the measure of each interior angle of what's called a 15 gon, that means how many sides are there? 15. Do you guys agree that no matter what, in any polygon, there has to be a spot where three sides connect? Even if it's a triangle, we would just close that up, but somewhere along the line, three sides will do something like that. I draw this figure for just about every problem because it works, okay? Here's the reason why I like to do this. I know that the number of sides is 15. I know that it's easier to find that outside angle because what's 360 divided by 15? 24. So if the outside angle is 24, what's the inside? See how much easier it is to work outside in? What I did there is this, 180 minus, and I did that. And that gives me my inside angle. So when you put that in your calculator though, you make sure that you throw parentheses around your fraction, okay? What's that?
For the second equation, no, not that. Can we put it over the number of?
Oh, the sum of the exterior is always 360. Every single outside angle.
You divided it by 50.
What I did there, that was to find each interior angle. These are three different things. Okay? So this is different. All right? There's just two ways to solve that question. I always find that it's easier to start on the outside in. Okay? Does that make sense by that drawing? Could you have done it this way, done 15 minus 2 times 180, hit enter, divided by 15? It gets you the exact same thing. Well, remember, it means the same. Okay? It means the same. What if we had to do this though?
Are we getting a worksheet?
No. If each, guys, if each interior angle of a regular polygon is 108 degrees, we need to figure out how many sides there are. So once again, what I'm gonna do is draw that diagram of the three-sided figure and fill in what we know. If I wanna figure out how many sides it has, if each of these inside angles is 180, what's on the outside? 72. That means 72 is on the outside. Now, if each exterior angle is found by dividing by the number of sides, isn't that just the equation? It's the supplement. They remember the outside and insides form lines. Okay. Isn't this fraction equal fraction? Whenever we had fraction equal fraction, remember all the tricks we did? Was it 2/4 equals 3/6? Was that true or false? True. If I flip them on the diagonal, I get 2/3 is 4/6. Is that true or false? That's true. If I go back the other way and say 6/3, doesn't that equal 4/2? If I flip them that way. All I'm doing is the good old-fashioned exchange-o, change-o. If I do the exchange-o, change-o here, I get that. So this is a great trick. It's a great, great trick to remember. You take 360 divided by your exterior angle, it equals number of sides. And it is so much easier to work with an outside angle than it is an inside angle. You can set up and solve the formulas and do all that fun stuff all day long, but if you just remember that the outside angles always add up to 360. If it's a regular polygon, that means they all have to be the same. So if 360 divided by the number of sides gives you the angle measure, that means that 360 divided by the angle measure gives you the number of sides. That's all I'm doing. I'm just reworking the equation by doing that exchange-o, change-o that you all know that we are allowed to do with fractions. Because we've been doing that since, what, January? Well, we didn't have that many fraction equal fractions. Well, we did in December with the chapter. Oh, I forgot, when you were did you get the Swedish meatballs at the IKEA with the curved keepers?
What did you just say?
They have cinnamon rolls though, right?
Yes.
The cinnamon rolls are really good. Their hot dogs are cheap too. Hot dogs are like $1.
Yeah, everything's
Yeah, I'm thinking about IKEA. I got the cinnamon rolls. Just thinking one is $1.
Yeah.
I don't remember how much they were, but I know they're pretty cheap.
And then they sell the 6 batches.
It is. It's okay. It's got 3 stories of gerbens and verbens and the gerbens and gerbens. Everything is in Swedish or Dutch, Icelandic, and that's how they
Just Swedish.
It's Swedish. So everything's written with a lot of umlauts and weird things. So they're all called the Skurfurben and Nervens. The Flurfernagen or Nervens. It's all weird. And they're all put together by Allen wrenches. But they've got great food. Why not?
Do you watch Friends?
Yeah.
Have you seen the episode where Phoebe
Why do we have to try and rush us?
She gives Rachel a massage and she's like, I'm IKEA.
Oh, I don't remember that one. I thought you were going with the couch going, pivot, pivot. Yes, sir.
So once we find how many sides pentagon or polygon.
What's that?
Once we find the number of sides, you also put the polygon.
Oh, it just says find the number of sides. Just say 5. That's it. That's all you do. Same idea. If each interior angle measures 144 degrees, how many sides does it have? If each interior angle is 144, that means how many degrees are left over on the outside? 36. Which means all I have to do is take 360 divided by 36, and it gives you the number of sides.
It's a decagon.
It's a decagon. It is 10-sided. That's why it's always easier to work with an outside angle than it is inside. Okay? Not too terrible for today?
Oh. Do we have homework?
Maybe a couple props. You can pull this. Sorry, put the wrong one up. Do those, please. I'm assuming you guys all remember how to get to the book, right?
Yeah.
That's been a while.
Oh, where'd it go?
I'll walk you back through it in a second. Remember, on the website itself, there's a drop-down menu that says chapter 8, because that's what we're in. When you click on chapter 8, the very first piece of information says, click me for the textbook. Where do you think you're going to click?
That.
I'll show you just in case you forgot. And I'll go back to this in a second. Chapter 8. Click here for the textbook once it loads.
And you click there.
Wait, is it 500? Is it page 510?
Yeah, I think so.
5-10. Pages 5
And
through 10.
don't freak out when you see this. It comes up as chapter 7. Each section of the book is broken down into 2 chapters. This so happens to be chapters 7 and 8, which means you have to scroll through to find chapter 8. Wow. Let me re-explain, because this is some real tough stuff.
Click chapter 7.
And there's your stuff, okay? There you go.